Well, first I want to apologize because everybody now is in a very relaxed state, and actually my talk is meant to rile you up, so, but in a good way. It's a good kind of riling up. Thank you very much for having me. Today I'm here to talk about what I believe is sort of almost a manifesto and a call to create a coup d'etat, and I'll explain a little bit more. This is called the Z80 processor. I grew up in Beirut, and I studied computer engineering, and this was the first processor that we started learning when we started engineering. I initially didn't want to be an engineer. My parents and my teachers thought I owed it to myself to become one because I was very good at math and science. And so I decided to go into engineering and thought that it would be an exciting journey. But then I started learning this. By the time we started learning the Z80 processor, it had already been obsolete. It's a processor that's actually very powerful. It underlines a lot of the computers that you see today and actually was really game-changing. But studying it was a very, very tedious process. It was multiple semesters of us learning the architecture of the processor, learning how to assembly code, learning how the inner workings of the processor are, and you couldn't get a feeling for why this was a powerful piece of technology and what it meant to the world. It was just a tedious, boring, dry process of learning electronics. But in fact, when I think about what I wanted to be, why I wanted to be an engineer, this is the kind of engineering that I was inspired by. This, for those of you who may not know, is the works of Theo Jansen, a Dutch artist who believes that there are no boundaries between art and engineering, and creates these creatures called the strand beasts that are made of PVC, of wood, and of articulations to create very, very human and organic looking forms using very complex engineering. I'll let you look for a minute. The incredible thing about Theo's work is that these are wind-powered. They have no robots in them. They have no motors. They're wind-powered, and so they're really one with nature. They're very, very complex contraptions, and yet they behave so romantically, and they walk so organically. And for me, this is the kind of engineering that I was inspired by. Engineering that sits in the background, that doesn't just come out and say, I'm technology. And that attracts pets in its process. And yet so much of technology that we see today and that we have seen over the past many decades looks like this. Devices that are finished, that are prescribed, that have behavior that has been defined by a large company or R&D department in a certain technology company that basically is assuming how you should behave with it, how you should interact with it, and really taking a finished state in your home. This is a snapshot of some products that are of the world of the Internet of Things that you may have heard of. The concept of the Internet of Things is this idea that our objects become smarter so that our lives become easier. So our thermostat talks to our fridge and tweets at us when we're out of milk. Or so that our garage door knows when it's open and sends us an email to know that somebody's trying to come in. These are all really interesting applications, and they should exist, but yet they assume such a very specific behavior that you have, and have these really prescribed definitions that we may not ascribe to. And more importantly, they have no magic. They have no organic behavior, and they have no feeling of being human or human-like or being one with nature. Now, you may say that why should we have technology that is more organic? And why should we even understand the technology that is around us? Why not just consume the technology that is around us? I believe that actually that's a really dangerous proposition. Because if you look at some of the fields that have really been bigger than us, that we haven't understood, and that we as humans have allowed to become more and more complex without participating, it's more often than not led to big disasters. So one example is the financial industry. But prior to 2007, the financial industry had become a behemoth of a field that touched everybody in the world, but we didn't feel connected to it. It became very, very complex, and a handful of people in the world were controlling it and understood it, and even then didn't understand it entirely. But then in 2007, 2008, when the financial industry collapsed, it touched every single one of us. It touched people in their homes and their jobs. It touched people in their mortgages. And you realize what it means when something is really a lot bigger than you, is so complex and you can't understand it. If it collapses, something dangerous happens. The same is happening with the electronics industry. Every piece of devices around us is a piece of electronics. Our cars, our elevators, our phones, our computers, our alarm systems, but we don't understand how they work. We cannot make our own, and more often than not, we just resign ourselves to being these consumers of technology, and I believe that's a very dangerous thing. In fact, a couple of years ago, when Hurricane Sandy happened, I saw this sort of firsthand play out. So I was in New York, and Hurricane Sandy hit, and as you know, a lot of New York was dipped into darkness. And I was really, I mean, I have these instincts of being okay with the power being out because I'm Lebanese, and so it triggers, you know, some survival instincts that are quite fun and brings in camaraderie. Obviously, I mean, there were a lot of very dramatic impacts to it, but you know, I'm making light of it a bit. But more surprisingly for me was this idea that I had people around me that I respect tremendously for their achievements and academic background and knowledge, people that were PhDs and masters in computer science that had no understanding of how the power grid worked. They would ask me, how come a few days after the hurricane passed, how come we still don't have power? Or how come lower Manhattan is dipped into darkness, but upper Manhattan has light? These sort of like misunderstandings of how a power grid is laid out, and misunderstanding of what it means to have a power station, of distribution, for me was a really dangerous thing. How could we really lack so much understanding of something that is so fundamental to us? So looking back at these things that we were looking at, these devices that are really made to make our lives easier, and this promise of cutting-edge technology that is going to change our life for the better, so much of it is reminiscent of the 30s and 40s and 50s. You know, when washing machines started, when blenders came about, it was all about, it's going to make your life better. You will sit back and relax while technology does work for you. I'm not very attracted to that idea, and it makes me feel really lazy. And so thinking back a little bit bigger, this was a really interesting quote that I found while doing research by Howard Rheingold, talking about the Internet of Things in particular and this next wave of technology. He says, "We will live in a world where many things won't work and nobody will know how to fix them." Newsflash, this has already happened. We already live in a world where so many things don't work and we don't know how to fix them. I don't know how to buy a television. I have 6 years of engineering and I know how these things work. I cannot buy a television to save my life. I don't understand what 4D versus 3D versus 4K. I don't understand what it means, and it really upsets me. And this is the world that we live in already. So what I'm here to call for is a coup d'etat. It's a coup d'etat against our things. And specifically what it means is a call for rebellion, which is apropos, to rebel against our things, to rebel against our technologies, and most importantly, to rebel against our mental laziness that says that it's okay to just purchase things and use them as other people have described to them. If we look at, you know, some other fields that have done that and done that successfully, you know, this is not such a complex proposition. Some of the technologies that have transformed the societies most have usually started in the hands of experts. Printing is an example, game development, software development, these were fields, manufacturing, these were fields that only large companies had control of. Only experts and engineers and people who were very well trained could have control over. They were very top-down industries, but they've been democratized. Software development has been democratized up to the point where anybody with a couple of weeks and a laptop can make the most popular software or game in the App Store. In manufacturing, it used to be that only GE could manufacture. Now you can buy a desktop 3D printer and you can do a small manufacturing business out of your kitchen. So how do we do that with hardware? So I won't go through a lot of detail, but this is the main idea behind how to democratize hardware. I look at it in 4 components. The first is lowering the barrier to understanding, and that's crucial because you have to understand what material you're looking at. Lowering the barrier to iterating so that people can participate and have small wins and really be able to get into the field. Making it universal so that it's something that is beyond a group, a small group of self-selecting people. And then raising the ceiling of complexity, because nothing is fun if it's too simple. So the way I look at democratizing hardware in particular, and this is sort of my take on it, and many people have done it differently, is basically trying to find a medium between, on one side, a circuit board that is created, that is highly complex, that somebody's built with their hand, that is a one-off, and on the other side, a finished product. If we compare it to software, same thing has happened already. We have on one side assembly code that is singular, that is tedious to write, and on the other side we have something like an app, which is a consumable. But in the middle, in software, you have object-oriented programming, a modular approach to programming, which became something accessible to other people so that they can participate and create their own. So what is object-oriented programming for hardware? A few years ago, I embarked on this process to do this research, how to create modular electronics. These were some of the first circuits that I made. They're made of cardboard. They have these electronics on them. Some of them are very simple. Some are complex. And the idea is that they're manipulatable so that you can put them together in little blocks, just like you would pieces of software. So the idea is that the modular piece would sit in the middle between the raw, the one-off, and the finished mass. So here's a video to show you a bit more about it. So littleBits is a library of electronic modules that are finished and semi-finished and assembled that snap together with magnets so you can create your own electronics. In the first example, a super stirrer by snapping 3 magnets. The second example, a wireless robot. In this case, a contraption to control your iPhone and be able to make nice videos. An automated water cooler so that you can time how much water you want and be able to avoid spills. A wireless bathroom sign. These are all inventions that were made by people that were not engineers, that were either industrial designers or artists or young kids or people that never thought of themselves as creative, people that never thought of themselves as able to create technology. But by creating these modular building blocks that are achievable, where you can have small successes, some of these circuits are very simple. They're buttons, they're switches, they're lights. Some of them are very complex, like cloud connectivity and wireless control, but they all have the same low barrier to entry. You start to snap things together, they make sense, and you start to build complex things gradually. The idea is that if we make building blocks, just like Legos, just like pieces of object-oriented programming, we make these modular bricks that you're able to grab onto and build out from, you're going to be able to really start to see your own threshold of complexity rise and start to create your own devices. So the library, oops, sorry. I did something bad. So the library that we call littleBits is over 60 modules. There are trillions of billions of different combinations, and it's not a finished product. That is the goal. The goal is that you create out of it what you want. So it's the opposite of something like this. It is not meant to have prescribed behavior. It is only what you make of it. So we've been working on this for many years. So littleBits is a company, and we create these kits for different people to create what they want with it. And the really exciting thing is to start to see what people make of them. So going back to the Internet of Things, I'll show you an example of some projects people have made. This first one is an SMS doorbell, so that when somebody rings your door, you get a text message, so that if you're wearing your headphones or you're in the garage, you're able to hear that somebody's at the door. Another example is taking an old air conditioner unit that is stupid and making it smart, making it internet connected so that you don't have to toss it in the garbage because somebody said that you should. Or saying that every day at 3 o'clock, I would like to feed my fish. Or I would like to create a contraption to show me how many likes I have on Instagram. I believe that it's not technology's job to judge you. It's not technology's job to impose on you how to behave. And it's not technology's job, and it's not technologists' job to limit the richness of your life. So what we've created is this library that is infinitely open, and it's open source, so that on one hand, you can create whatever you want, and on the other hand, you can make them for yourself, and you can keep expanding on them if you wanted to. The goal is to really counter this closed culture and be able to create things that are connected to the internet, that are silent, that are for the home, that are for the office, that you invent for yourself, that maybe nobody else would have made for you. These are some of my favorite projects that we've seen recently people make. And the very important thing to note is none of these people had any background in technology. None of these people had ever any desire to get into technology. In the upper left corner, it's a little bit tough to see, but in the upper left corner, we have something called a squirrel cam. This squirrel cam is by a family that wrote into us and said that they had a problem because a family of squirrels had just moved into their house. And they wanted to be compassionate people and not try to trap and kill the squirrels, but at the same time, it's pretty annoying to share a house with a squirrel. And so what they made is they made this grill that had a motion sensor and a camera, and anytime a squirrel comes in, the door shuts and the camera takes a picture, so to prove that the squirrel was there. It's a very humane, playful project that likely will never make it into a product. No company is going to sit in a boardroom and say, we're going to invest in squirrel trapping mechanisms to help. This is not something that a company is going to make for you. There's not enough of a market. It's not scalable enough. But that doesn't mean that this person, this family, shouldn't have it. We shouldn't be able to bend technology to make that for us. In the upper right corner, another example from a family that lives on a farm outside of California. This is a family that has 6 chicken. And I don't know why there are so many animal projects, by the way. It just happens. This is a family that has 6 chicken and 2 daughters always fighting over whose turn it is to feed the chicken. And so the dad gets upset because he has to go out and carry the bag of chicken feed and check whether or not they've been fed and then tell his kids to do it. And so what he's made is he's put together some littleBits to have these sliders that are measuring how much weight there is in the chicken feed bag, and then using a cloud bit to transmit that information to his phone so he can see on his phone whether or not the chicken have been fed. Again, a very specific project that will never turn into a product, but that does not mean it doesn't deserve to exist. And then the last project, which is actually my favorite, is it's a two-way communication between a bunny and a family, so that the bunny can tell the family when he's hungry. And so he steps on this button, the button sends a text message to the family to tell them that it's now time to feed the bunny. And actually, they've been able to train him to do that. So that's, for me, it's a really magical and adorable thing. So to go back to the manifesto, a coup d'etat against our things, to bring back our things to be working for us, to bring back our things to be at the service of people and not us at the service of them, not us to say, oh, my machine doesn't do that, my robot doesn't do that, oh, I've never found the proper product for it, and to sort of live at the mercy with this very passive mindset, but at the same time to do it with grace, to do it with fun, to do it with playfulness, and to do it with invention so that we can inspire ourselves and inspire the next generation. Or pets, of course. Thank you.